Welcome back to geometry class. Let's continue with this topic called congruency of triangles. Remember in a previous lesson, we talked about the first two cases of congruency. Remember, in order to prove two triangles are congruent, it's not necessary to prove all six corresponding parts are congruent, but a certain combinations of parts. Yes? In the previous lesson, we talked about two such combinations. In fact, there are a total of 4 combinations. In this lesson, we're going to talk about the next 2 combinations of corresponding parts. These combinations are ASA and AAS. But for now, we'll talk about the first one, ASA. Now, A stands for angles. S stands for side. As I said in the previous lesson, each of these letters represent a pair of corresponding sides. Good. Now, what does ASA case state? If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Now, what does included side mean? So, included side means the side that is between angles, two angles, right? In these examples, this side, which is JG, is between these angles, right? Is between them. That's why we call it included. In this case, this side, JH, is the included side because it's between angles. And in the third case, is the same thing. Yeah? So, let's go back to our first slide. And now, let's fill in the blanks. So, first, we have to come up with a pair of corresponding angles that are congruent. What are these angles? As you can see, A and D are marked the same. Yeah? So we can say angle A congruent angle D. Now we have to find a pair of corresponding sides that are congruent. What are these corresponding sides? Are AB and DE. Why? Because they have the same number of markings. So we say AB congruent DE. And we need one more pair of corresponding angles. And these angles are B and E. As you can see, they are marked with the same. Yeah? So we can say angle B congruent angle E. So if all of these 3 statements are true, then we conclude triangle ABC congruent triangle DEF by ASA. Now let's have an application with this case. For example, in this example, we have to prove triangle QRS congruent triangle QTS based on this case, ASA. Now, what is given? Is given SQ bisects angle RQT. So, QS bisect angle RQT. Now, if SQ bisects angle RQT, bisector QS will cut or divide the whole angle, right, into two other congruent angles, yeah? So, which means these two angles, the resulting angles, right, would be congruent, because bisect means cut in half. So, we can say, here is given, yeah, the first statement is given. Let's write given. So, we can say RQS, angles RQS, congruent angle TQS. Why? Because the property of bisector. So, let's say property of bisector of SQ. So these angles, right, would be congruent because QS cut RQT into two congruent angles. Also, RSQ congruent TSQ. RSQ congruent TSQ. Why? For the same reason. Because SQ bisects both angles, RQT and RST, right? So we can say here, because of the property of bisector. Good. Now, we have two A's, right? This is the first pair of A, this is the second pair of A. What is missing in this case to prove these triangles are congruent is missing a pair of sides, the corresponding sides. So we have to find out this pair of corresponding sides. If you look carefully at this diagram, we can see QS, side QS, is a common side for both triangles. QS is shared by both triangles, right? So we can say QS congruent QS by reflexive property. This is S. So we have A, S, A. So, conclusion, triangle QRS congruent triangle QTS by ASA. Good. Let's move on to another case. So-called AAS. What does this case state? If two angles and the non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. Yeah? So, what does non-included? I'll show you what does non-included side means. A side that is not between angles, the given angles. For example, you see these two angles, right? A non-included side could be this side. Why? Because this side is not between angles. Or this side. Yeah? Good. Let's go back to our previous slide and let's fill in the blanks here. Now, we need to come up with two pairs of corresponding angles and one pair of corresponding sides. Now, we see here angles A and D are congruent. Why? Because they are marked the same. Yeah? So we say angle A congruent angle D. Good. Next, we have to come up with another pair of corresponding angles. And these angles are B and A. They are congruent because they are marked the same. So angle B congruent angle E. And then the non-included side. As we can see, BC is non-included. In other words, is not between the given angles, right? And EF also is non-included. And because they are marked with the same number of markings, they are congruent. So we say BC congruent EF Now, if all of these statements are true, then we conclude triangle ABC congruent triangle DEF by AAS. Now, let's have an example with AAS. Good. Now, we have this diagram. We have to prove triangles WYZ, congruent triangle XYZ based on AAS. So we have a few things given. We know YZ bisects angle WYX. So we write here YZ bisects angle WYX and is given. Good. What else is given? Angles YWZ, angles YWZ, congruent angle YXZ. Let's mark them. Remember, we follow the order of letters. So YWZ, this angle, right? Congruent angle YXZ. YXZ. These angles are congruent. Good. So, for now, we have 1A given. Yeah? We need two more corresponding parts. We need one more pair of corresponding angles and one more pair of corresponding sides in order to prove these triangles are congruent. For now, we have just one pair of corresponding angles. Yeah, is these angles, this pair of angles, right? Probably let's use another color to emphasize these letters better. Yeah. Now, so let's use the given information to find the missing corresponding parts needed to prove these triangles are congruent. So, what we know, YZ, segment YZ bisect angle WYX. Because YZ bisect this angle, right? Cut these angles into two congruent other angles. So we can say angles WYZ congruent angle ZYX or XYZ. Because YZ bisect the whole angle. So we can say angle WYZ congruent angle, let's say XYZ. Let complete fill in the blanks. So here is a given, right? And here they are congruent because the property of bisector YZ. So we have the second A in this name. Yeah? So let's put the second A here. Now what is missing? An S. We have to find a pair of corresponding sides that are non-included in order to prove these triangles are congruent. Now, what side would be non-included, in other words, are not between these angles, and are congruent? For example, we see YZ is a common side for both these triangles because is shared by both. So we can say side YZ congruent side YZ because it's a common side by a reflexive property of equality. This side. So we can conclude triangle WYZ congruent triangle XYZ. This is S, yeah, the last letter in this case, yeah, by AAS. So we're going to have a few more practice problems with all of these cases, but for now that is all we have. We'll see soon with other topic. Be safe and see you next time.